Down. So let's keep going. So in order to make it a little bit interesting with our presenters today, I thought we'd get a little bit personal with them. I asked them a couple of questions. I asked them what was their first data-related job, and then I also asked them what is just one fun fact. So I thought this would just give us a way to kind of understand a little bit more behind the presenters we're going to have up today. Our first presenter, his first data-related job was with Tata Group. He was a senior officer back in 1996, so a little while ago, 20 years ago or so. And his fun fact is he's been cooking since he was age 10, and he still continues to actively cook. He caters for large groups of 100 or more. So with that, let's invite Sumeet Singh and see what he's got cooking for us today. Sumeet from Yahoo.
Thank you for the introduction,
Thank you.
John.
There you go.
Pleasure. All right, so good morning. I've been doing a lot of talks at this venue for the last 5-6 years. Perhaps my last one in purple. We're officially Verizon as of yesterday, just in case you didn't know. So let's talk Hadoop. So in the last 11 years, Hadoop has been the quintessential cloud platform for Yahoo. And the platform has continuously evolved to meet the new demands or evolving demands as we saw them. And it's this constant shaping of the platform is what that has allowed us to stay strong and mature the platform over these years. Right? So what I want to do in the next 10 to 12 minutes is to walk you through how we have shaped this platform and now how we have evolved it to meet new use cases, new demands as they have emerged on the platform. Okay? So just to set context, the platform, the data platform at Yahoo, brings all the data producers and data consumers together across all our businesses, offering a variety of services to them. And it doesn't really matter what the business is. It could be search, advertising, communication, media, or other types of businesses we're in. But they're all brought together on this common platform. And the idea is that we deliver business benefit to these businesses, and then they, in turn, power the consumer experiences that Yahoo is known for. So obviously, we see a lot of diversity in our use cases. Over the years, we've also scaled up the platform fairly nicely, as you will see. And what that has allowed us to do is to bring the marginal cost down for every tenant. Tenant here is a use case or project. Either for the existing tenants or for the newcomers who come onto the platform. And the platform has fostered a really good breeding ground for innovation or newer paradigms for processing and managing data as we have evolved it. And it's this evolution which I think is key to the success behind the platform. So let's talk about compute first, because that is the basic unit of work on our platform. So what this chart shows is percentage share of 3 compute engines we run on our clusters. So all clusters run Tez, Spark, and MapReduce. And this is a chart, a daily sort of compute share over a period of last 17 months. And you can see here that we've been constantly shaping the nature of compute on the platform, moving a lot of workload or share away from MapReduce over to Tez. And most of that comes from Apache Pig for us and Apache Hive. Right? So from almost nothing, it's now nearly 70% of the compute share on the platform, and Spark's pretty consistent as well. So this chart doesn't mean that the compute is not growing. It's just a relative share of these compute engines. So obviously, thousands of hours have gone in, both from us and the community, to make this a reality. And what this compute shaping does is that it allows us to make better use of the platform. That, in conjunction with a lot of work we have done on the scheduler and capacity management processes, have improved our utilization over the same period. So this is, again, that 17-month period, last 17-month period. And you can see the used capacity across the platform. Now, I'm talking about all production and non-production environments collectively on a daily basis. And you can see that from low 40s, 50s, the utilization has improved now to nearly 70s. Storage actually is improving as well from a utilization standpoint. So this is fantastic. This is fantastic for the company. This is fantastic for our customers because they can make better use of the available capacity. Now, Apache Storm is the real-time platform at Yahoo and has been for the last 5, 6 years. Um, and early on, a lot of our focus was in scaling Storm clusters, improving the usability for our users. But last year or so has been a lot about what we call as resource-aware scheduler, right? So we've been constantly in the quest for moving old topologies, old tenants, from the old multi-tenant scheduler over to this new resource-aware scheduler. And that has really come to fruition in the last 7 months, which is what this chart shows you. And as these topologies have migrated from the old multi-tenant scheduler to the resource-aware scheduler, you can see that the compute efficiency, both for CPU cores as well as memory, has continued to improve. So again, we're talking about high 40s, now well into 60s and 50s for both CPU cores and RAM. So again, fantastic for our Storm customers as well as us who operate the platform. Now, there's a lot going on here, but let me explain. So Apache HBase, for a lot of our customers, serves as the glue between batch and real-time worlds. Right? So what you see here is region server throughput from a single multi-tenant cluster. There are about 45 tenants on this cluster, and it does look pretty chaotic. So the question is, well, how do we shape random access on a shared multi-tenant cluster when the workloads vary this much? The other reason why workloads vary this much is because a vast variety of tools, both batch and real time, are reading and writing into HBase at the same time, right? So what we have done is that we have introduced a concept called region server groups several years ago, and we've been constantly sort of improving that. But when I separate out the tenants and their workloads, now that chart, the same chart, broken down, doesn't look all that chaotic, right? So this is the way we provide coarse isolation on our HBase clusters by separating out tenants as groups and while maintaining the throughput and performance SLAs or latency SLAs for our customers. Right, so pretty key technology for us in terms of bridging the worlds. Of course, no data platform is complete without a comprehensive analytics, warehousing, reporting, or BI solution, whatever you want to call it. And while we use a number of technologies in the analytics space, Apache Hive is really the predominant tech we've been shaping for the last 5 years. We started way back in 2012 with Hive 9, and as you can see over the years, in multiple stages, the evolution of the platform has really been about lowering the latency and improving the performance. Right, so we're now with Hive 1x, moving on to Hive 2x, and you can see that sort of improvement in latency. But just to set things in a better perspective of how that shaping has evolved, I'm going to walk you through some numbers. So this is all the queries, all SQL queries that ran on our clusters last month, right, in May. So about 2 million queries that ran last month. And what I've done here is that created bins of latency. Now, this latency here is pure DAG runtime. There is some start and prep time, which I've not included, just to keep things simple. And you can see that vast majority of our queries, about 75% of them, finish in about a minute. Right? So sweet spot seems to be in that 17-second range when you're processing about 5 million records. Right? So 55% of queries are finishing in that time. Obviously, there are 25% of queries which sort of take minute or minutes. But just to, again, put things in perspective, we're processing 500 million to roughly 16 billion records on an average, each of these queries, right? So which is why it's taking that long. They're different in nature than the generic queries that you experience. And again, the quest here is to push this curve, sort of the bigger bars, towards the right side of you, into that 0 to 10-second range. And we're on our way with in-memory and other techniques. OK. So, a lot of shaping has happened from a tech standpoint, framework standpoint, but we've also been shaping our infrastructure as demands are evolving. So our infrastructure is fairly generic. We run JBOD servers largely. They're all connected to a network backplane, which is fairly large, supports about 20,000 servers. But what we have done lately is that we've introduced GPU servers, which are connected directly with a high-speed InfiniBand network, 100 gig in this case. And then we've also introduced very high memory servers in the same racks where generic CPU servers live, right? And what this has allowed us to do is that this has allowed us to introduce newer paradigms of processing for large-scale machine learning, for deep learning. And we use node labels extensively to target applications to these specific specialized hardware as they need these processing units or compute power from the clusters. We're perhaps going to use the same node label technique for ultra-low latency analytics as well, or the in-memory analytics I was talking about, just to distinguish the queries from, I would say, the ones that need generic processing versus the ones that need ultra-low speed processing. And this is how we've evolved our stack to support large-scale machine learning. So most of the components have stayed the same, except the fact that we've introduced a homegrown parameter server that allows us to share the parameters when we distribute learning. So that's a key piece of tech that we have evolved. We've also introduced a number of scalable algorithms on the platform, word-to-vec, the gradient booster decision trees, things like that. Algorithms that our customers need, right? So we work on scaling those. And there are two specific frameworks we have open sourced in the last 1 to 2 years. One's called Caffe on Spark. The other one's called TensorFlow on Spark. And I encourage you to look at both of them, which sort of highlights our technique of RDMA on InfiniBand for distributed learning or fast learning. Of course, we support notebooks for easy development, experimentation, and sharing. And the models are served via our Elastic Serving Paths, right? So that's the setup here. And over the years, we've also been shaping the user experience, because I think that's fairly important. So we have introduced hosted development UIs. We're pretty much well on our way into self-serve onboarding. Not 100% there, but pretty close. Complete resource transparency, both for tenants and the infrastructure. Complete cost transparency in terms of what it's costing the tenants to run their use cases on the platform. Basic discovery, basic governance, as well as really insightful tools that gives you deeper visibility into what the users are doing on the platform. And many of these tools are actually used by our end users, right? Not just by us. So I believe that these 5 factors have contributed to the success of our platforms as we have shaped them over the years. The first one, of course, is a platform mindset, right? It requires sustained investment over longer periods of time. You can't expect magic overnight. The other important thing which actually has contributed to the success of the platform at Yahoo is that we offer everything on our platform as a service. We don't require our customers to do a lot of setups or installs. There is also a really decent tech ecosystem where different pieces work well together. So there are lots of services at people's disposal. Open source, of course, is big for us. And the mighty shapers in our team, right? So that's also a huge reason. So thank you. You know, I have shared a lot and learned a lot here at this venue, and I hope you do the same. Thank you.
Thank you. Sumeet, thanks very much. All right, so good examples of HBase and Hive at massive scale, in keeping with sort of the tech behind big data and some of the things and technologies, and certainly Yahoo being amongst the earliest of using the technology and using it at a massive scale gives us some great insight there. So we've determined that it was an